Good morning, ladies and gentlemen. Welcome to UE System webinars. This is Spencer Tang from UE System Asia office. I'm stationed in Malaysia with a branch office in Hong Kong. We hope you are safe and well during these challenging periods. Before we start the webinar, there are a few housekeeping rules for reminders. This webinar will be recorded and the video link will be shared to you after the sessions. Second, along the webinars, if there is any questions or comment, please feel free to write in the chat room or email to us and we shall reply to you accordingly. And lastly, as we are in a live webinar, please kindly mute your microphone to avoid unintended noise interruption. Let's begin our webinar for today. Today, we are going to talk about ultrasound in predictive maintenance, plant safety in terms of electrical inspection, bearing lubrication and monitoring, leak detection on compressed air, gases, and its financial impact in terms of cost saving and return of investment, ROI. Sound is categorized to three main groups. Infrasound with sound frequency less than 20 Hz, audible sound with sound frequency between 20 Hz to 20 kHz, and high frequency sound or ultrasound is with sound frequency above 20 kHz. Ultrasound is commonly used in the industry. Ultrasound is used for structural testing, such as thickness measurement, flaw detection, distance measurement in architecture, medical, and intensive cleanings. However, today we are focusing on machine diagnostic and monitoring using airborne and structure-borne ultrasound technology, which is also compliant to ISO 29821 requirements. Airborne ultrasound and structure-borne ultrasound works under the principle of turbulence, ionization, friction, and impactings. It is applicable to leak detection, regardless of leak out to atmosphere, leak within component of pipeline, or even vacuum leaks. It detects electrical ionization activity, friction and impacting symptoms caused by rotating bearings and hydraulic system. The detection methodology is based on noise decibels, or dB, and noise qualities. Ultrasound device pick up machinery ultrasonic signal through airborne or non-contact methods. Ultrasound device detect compressed air leakage along the pipeline. Electrical ionization activity from the overhead tower. Or from the main switchboard. Or even, it is applicable during offline leak detection in condenser repair. Besides, ultrasound also being picked up with direct contact to the facilities. We can perform direct comparison to differentiate the good one and the bad one. For example, when we are checking on bearings, we can easily know which bearing is good and which bearing is bad by comparisons. This is a bad bearing. The noise is very rough, comparing to the good bearing. A very smooth rotating bearings. We also can compare the inspection result on steam trap. A good steam trap with a regular rhythm open and close. And a bad steam trap with a complete flow through. From the maintenance perspective, machine is like our human body. We fell sick once in a while, and we will shut down when getting older. Same goes to machine. Every machine will fail over time. We perform body checkup to get know about our body condition. we perform condition-based monitoring on critical machines to know their fitness status for the sake of reliability and availability. Ultrasound is the earliest detection upon the occurrence of fault symptom under the principle of turbulence, ionization, friction, and impacting, followed by the movement and displacement, which will be picked up by vibrations. Chemical reaction and composition content through oil analysis, and minor heat generated that detectable by infrared thermography. All these testing are under condition-based monitoring. Data is collected and will be analyzed, trained, and integrated to provide substantial information about the machine condition, so that maintenance team will be able to generate a comprehensive maintenance decision whether to continue run as it or shut down immediately, schedule repair, system upgrade, or replacement. With all the data and information, our engineering team can just sit back and relax, as everything is under control and being monitored. However, if these early fault symptoms are not attended and further deteriorate over time, then breakdown is unavoidable, and this will end up with firefighting condition. Basically, there are two types of maintenance, time-based and condition-based. Run to failure and preventive maintenance are time-dependent. However, predictive maintenance is more focused on machine condition monitoring. It is data-driven with objective trendings. In predictive maintenance, we talk with data and trending. There are less chances for try and error. No more, I think, I feel, I assume, or I believe. If there is a deteriorated fault, we show the graph of deterioration. Ultrasound provides dB trending to trend the fluctuation of the fault symptom through data management system DMS UltraTrend. If there is an improvement, we also show the trend of improvement. If there is a success story, we also show the trend of proof on how good is the audit or how good is the practice over time. UE ultrasound device is one of the effective tools in plant's predictive maintenance program. So let's look at the ultrasound application in plant safety in terms of electrical inspections. Electrical system is the heart of a plant. A power failure will lead to a total shutdown of a plant operation. Electricity is not visible, not audible, odorless, and not touchable. We use infrared to see what we cannot see. We use ultrasound to hear what we cannot hear. Ultrasound is here through panel door, gap, air vent, and opening. If we have a visual access, then we can assess or evaluate or detect the symptom through a directional access. Ultrasound device is applicable in indoor application or outdoor inspection. We can apply it on outdoor transformer, outdoor switchyard, or even overhead towers. Let's look at a short video about power system inspections.
When flashover happens, the results can be devastating. Detect and analyze potentially catastrophic conditions before they happen with the UE system's remarkable ultrasonic ultraprobe 15,000 touch. Sense ultrasonic emissions of arcing, tracking, and corona in open or enclosed systems, whether heat is detectable with infrared or not. Scan at a safe distance with a long-range module or enclosed switchgear. This is the sound of corona. Not detectable with infrared. Record the sound and save it. Take a photo of it. Many electric inspection protocols call for using ultrasound to test enclosed electric gear before opening to prevent arc flash incidents. Inspecting electric gear of all voltages with the UltraProbe 15000 is fast, accurate, and safe.
Electrical partial discharge is an attempt to bridge between phase to ground or phase to phase. There is 3 distinctive electrical partial discharge symptoms: corona, tracking, and arcing. This activity will generate ionization, which produce ozone and nitrogen oxide. Nitrogen oxide will form nitric acid with moisture, and nitric acid is very corrosive to insulation and conductors. Corona. Corona, or we can call it as cancer level 1, only occurred at over 1000 watts and above, halfway to ground, but has not found it. It will no heat and undetectable by infrared tomography. Corona have a unique noise quality with steady buzzing. So let's take an example about corona detection in VCB cubicles. We detect corona partial discharge at the VCB cubicle with 2 dB, a very slow and low decibel. The corona noise is steady and consistent. For a louder noise, the detection can be achieved in a further distance. This is a 17 dB corona detection. Without opening the panels, we can detect the partial discharge through the gap and the vent. Secondly, tracking partial discharge. We can categorize it as cancer level 2. Low heat, detectable by infrared tomography, but usually being ignored because the temperature difference is too low. It's forming a carbonized tracking tree at the surface. The unique noise quality is inconsistent popping noise and with wavering volumes. This is some example about tracking partial discharge found at cast resin and vacuum bottles. Arcing, or we can call it as cancer level 3. When arcing is present, failure is occurring. It comes with a violent buzzing noise similar to a firecrackers. Let's look at the examples. Infrared and ultrasound is actually complement each other, especially in electrical partial discharge inspections. Infrared detect heat at the panels. However, the temperature delta is very low. Complemented by ultrasound detection, the arcing noise will show that the severity of the panels. Besides, we also have found arcings from the cable through the real panels inspections, through the gaps and through the vents. So some of the end user will ask, and we are afraid that we are not able to differentiate. But don't worry about this. We recognize noise. When our mothers or our father call us in the telephone, we can immediately recognize the noise because we know the noise quality. Same goes to electrical partial discharge. So when we get used to the tracking noise, corona noise, arcing noise, we can differentiate it easily. So for safe inspection with ultrasound, ultrasound provides a safe method for electrical inspection from a safe distance. It provides a directional access to pinpoint the fault location. Electrical partial discharge noise is unique, and this will enable repair prioritizations. Besides, NFPA 70E also recommended ultrasound inspection in electrical partial discharge detection. We shall continue with the mechanical looseness discussion in electrical application in the next webinars. Now, we shall proceed into mechanical application in rotating bearing lubrication using ultrasound. Lubrication or greasing is a routine task to maintain the bearings. However, not all the bearing is greasable. We can grease at the open bearing and shielded bearing, but not to a seal bearing. Majority of the bearing failure are caused by lubrication. Today, we will focus on over-lubrication issue. Over-lubrication means more is not always better. Industry usually face a common problem after bearing lubrications. High temperature alarm at the bearings. However, the alarm will normalize after 2 to 3 days. This is the symptom of over-lubrication. Too much grease within the bearing reduces the heat dissipation rate within the bearings. A bearing housing that compact with excessive grease increases resistance to the ball bearing movements. So, how much to grease and when to grease? We grease according to the recommendation from the manufacturer, based on the grease plate. All right. So this is just the manufacturer guideline or recommendation to the end user. Manufacturer have no control about the loading, how much you run the motor, whether in 100%, whether in 20%, or whether in 50%. They have no control how you locate your motor, whether you locate the motor at outdoor or indoor, you locate the motor in hot temperature or in underground. So this will also affect the grease consumption within the bearings. UA system recommend condition-based lubrication using ultrasound. We grease the right amount of lubricants according to the needs of the bearing. We skip lubrication on good bearing and we look on bad bearings. For good bearings, it sounds a very smooth noise, such as a waterfall noise. Whereas for bad bearing, the bad bearing sound rough. When we look using ultrasound techniques, so we can listen to the grease movement and the reaction of the bearing when the grease reaches to the bearing. So when the grease reaches bearings, friction reduce and the noise decibel automatically will reduce. So this is the tips about lubrication with ultrasound. If a bearing needs grease, when the grease is applied, dB will fall. For example, for these small tables, dB will fall when the bearing receives the grease. Friction reduce, decibel will reduce. When come to certain point, the decibel will become stagnant. And once there is a rebound of decibel, it is the indication to stop. So let's take a look about the lubrication videos.
Stop killing your bearings. Improper lubrication is one of the most common causes of bearing failure. If you use standard time-based lubrication practices, your bearings are at risk of over-lubrication. Use condition-based lubrication featuring a digital ultraprobe and the ultrasonic grease caddy to prevent premature bearing failure. Here's how. Identify bearings in need of lubrication through routine monitoring. Create a lube route. Use UE Systems grease caddy, analog or digital. Attach the grease gun to the grease fitting. Note the intensity level and listen through the headphones. Apply the grease while listening. Stop adding lubricant when the drop in intensity level is observed. That's how easy it is to prevent over-lubrication. The ultrasonic grease caddy. Reliability never sounded so good.
This is an example about lubrication assisted by ultrasound. Before lubrication, the sound is rough. After lubrication, it becomes very smooth. The end user have a problem beforehand. They're usually having a normal grease stroke of 25 strokes. By using ultrasound, only 8 strokes is required. This instead saves the greasing cycle time, lubricant costs, reduce the bearing failure, and we are confident that the bearing is properly lubricated. Instead of we grease and grease until the lubricant is pushed through the shaft or flow out from the grease nib, then only we realize that we have over-greased the bearings. So the grease nameplate is just a reference for everybody's. Still, we need to grease according to the needs of the bearings. UE system offer 2 types of grease caddy for bearing greasing. UP201, an analog device with LED indication, and UP401 with digital dB value displays. Now we will proceed further to conveyor bearing monitoring. A take-up roller bearings. A routine condition-based monitoring practice is applied on these take-up roller bearings. The monitoring database was started since year 2015 to 2017. 2015 to 2017 as the baseline of 17 dB on September 2015. The alarm level was set according to ISO 29821 guideline, with 8 dB above baseline as low alarm and 16 dB above baseline as high alarm. Means 17 plus 8 become 25. 17 plus 16 become 33. The bearing was hitting the alarm level continuously starting in December 2016. We can see the numbers and we can look at the alarm status. We can also have a better view in graphical displays. And we make noise quality comparison between the baseline and the alarm level. This is the baseline. Although this is not a good noise quality for a normal bearings, but we can't just replace every bearings. Bearing is a mechanical component. It will fail over time. So by condition-based monitoring, we can monitor these bearing conditions. And this bearing give way after 2 years with a very rough noise quality. With the data, the decision is to replace and dismantles. From the diagnosis result, engineering team found that there is a severe damage within ball bearings inner race, and this also caused a worn shaft into the bearing race. Thus, we can perform conveyor bearing monitoring via Airborne or non-contact method on pulley bearings, and structure-borne or remote magnetic sensor at the bearing housing. So at this moment, we'll on hold again the rotating bearing discussion till the part 2 webinar. Now, we are at our last session of today's webinars, leak detection on compressed air and gases. Air or gas leak detection is the most widely used application for ultrasound. It shows the quickest ROI and cost saving once the leak source is rectified. For UE system ultrasound device, minimum pressure need for leak detection is 5 psi or 0.3 bar. Compressed air is free. Although air is free, but compressed air is not free. Compressed air is generated with electric power. We pay for the electric bill. 30% of the compressed air generated is lost due to leaks. The more leak we have within a pipeline system, our compressor will work longer hours to sustain the pressure in the vessel. Thus, the compressor servicing routine will be more frequent. We pay for the compressor service cost as well as the repair cost. For example, if we have a leakage occurrence along the pipeline, the compressor is running 24 hours. So it will require 7 months for a new servicing routine. If we can reduce the leakage and the compressor running hour is reduced to 14 hours per day, then we can actually prolong the servicing period of the compressors. So if we're having air or gas leakages 24/7, we are paying for the electric bill. If there is a gas leaking, we are paying for the gas cost. We're also paying for the compressor service cost and as well as to the compressor repair cost. So compressed air is actually not free. Air and gas movement in turbulence flow will generate ultrasound. So it's regardless of leak out or leak in. As long as there is a pressure difference, turbulence is generated and ultrasound is detectable. Is it applicable for compressed air, vacuum system, or even gases like nitrogen, oxygen, acetylene, hydrogen, and etc. We can perform leak detection at the knee level or even overhead. The leak is detectable at the fittings, at the filter, or at the regulator. So this is a short video about how to perform leak detection using ultrasound. For leak detection, scan using the gross profile method, scanning in all directions and adjust the sensitivity along the way. Look and hear for the loudest leak noise. Adjust the sensitivity to get closer to the leak tag or to the leak area. Then we locate the leak point and tag for repair. Measurement of the leak decibel will enable us to do cost-saving calculations. And finally, we take photo of the leak locations. UE system developed cost-saving report through DMS Ultratrend software and leak survey applications. The cost estimation is based on decibel, pressure, and cost per kilowatt hour of electricity. This is an example of the cost-saving report for compressed air. We will have a saving of $6,700 USD for this example. But if the leak involves expensive gases, the user will achieve his ROI in a very short period. For example, if we are doing leak detection on nitrogen or helium, this is considered expensive gases, and the saving will be huge. This amount of 27,000 USD is good enough to pay up the instrument with extra saving for the companies. So as a conclusion for today, ultrasound is already become an accepted tool for diagnostic of both mechanical and electrical fault. Ultrasound is applicable for mechanical application in terms of rotating or static applications, and even is applicable to electrical partial discharge detections. And we use decibel, dB, as the indicator to trend or monitor a potential problems. And ultrasound is also being used for lubrication so that we can apply sufficient amount of grease to the bearing in order to avoid over lubrication. And lastly, ultrasound application, especially in leak detection on air or gases, is the quickest return of investment of your instruments. And this is about the instruments of UltraProbe 15,000. For those who are interested about this unit, you may visit UE System website for a detailed information. This instrument is portable and is applicable for electrical application as well as mechanical application. We thank you for your time and participation. We hope to see you again in next webinars. And if there is any questions, please email to us and we shall reply to you accordingly. For more case study or references, there is available in UE System website under Learning Center. Thank you, everybody. Bye-bye.